that because we Brazilians are so creative, we can adapt to anywhere. And we have a lot of smart Brazilian people, lots and lots of really good scientists. And people, like, they would fight to have a Brazilian in their lab because we are hardworking and creative people. She was spreading salmonella to all the houses that she was working. So then they took her to the hospital, but she refused treatment because she was not feeling anything. And then she changed her name and went back to work for other families. And then again, they found. So then they ended up locking her in a hospice because she would refuse treatment because she had no symptoms. Yeah, so when I started my career in Brazil, and also the technology that was back in the day, one experiment would last 3-4 days. And now with things going further, like all the evolution thing, the same experiment that would take me 3 days to do, now I can do in half day.
Future Hacker. Life. Path. Future.
Hello everybody, and welcome to Future Hacker. I'm your host, Maria Taiji, and today I'm talking with Liliana Moura Massis. Liliana is a distinguished scientist in immunology working with research in autoimmune diseases, with a rich background in biomedical sciences from Universidade de Mogi das Cruzes here in Brazil, with a PhD in microbiology from USP, which is the University of São Paulo. Her extensive career began as a clinical laboratory assistant and progressed through prestigious roles, including a visiting postdoctoral scholar at Harvard Medical School and a research scientist at Stanford University. Liliana's deep dive into microbiology and immunology has culminated in her current role, where she continues to make valuable contributions to the field. With her Brazilian roots and Silicon Valley experience, Liliana is not only a respected scientist, but also a mentor and advocate for women in science, embodying the innovation and dedication that propels healthcare and medicine forward. Hello, Liliana. It's so great to have you with us today. How are you doing?
Hi, thank you. Thank you for the invitation. I'm really glad to be here. I'm doing well. Yeah, I'm right now in Monterey, California, in an immunology conference. So it's super exciting. And we are going to talk more about this.
Any news from the conference, just let us know right away, Lily. So, I absolutely love talking to women in science. And let's begin by your journey, like we usually do. So can you just describe to our listeners your journey into science? It all began here in Brazil, including what inspired you to pursue this career, especially here, which is, usually harder when you compare it to other countries. And, how was it to journey into biomedical sciences and immunology?
So I was a very curious kid. And then I remember my biology professor giving me the class about Mendel's law, how crossing two peas you could get different combinations of things. And I loved math, but I didn't see myself being an engineer or anything related to math because I like to take care of people. So my thing in life was how can I cure all disease of the world? So I used to talk to my uncle that is a doctor and he has a clinical lab, and tell him we would make crazy plans how we could save the whole world. This I was just a teenager. So then during high school, I started to look more towards it, which school I could go. And then I figured out that a biomedical school was the best option because then I could be a scientist, study science and relate to human disease. That was I was more interested in doing. So then my mom was a professor at the University of Mogi das Cruzes. So it was convenient for me to study there. And the university was the best school in biomedical. It was one of the best in biomedical science. So then I knew okay, I'm going to have a good education here. And I don't want to stay another year or two to be able to get into a public school. And I'm going to make my career as a scientist here. So first day of school, I got an internship position in a clinical lab where I started learning all the departments. And this is something that I want to comment a little bit. Back in the day, there was barely no machines. I don't want to tell my age here, but that is more than 20 years ago. So was the labs, and we can talk more about it later, about
Yeah.
robotics and how it's changing the biomedical science and high throughput of things. So then I learned all the departments of a lab, and then was one of the departments that was parasitology. I don't know if people will get too disgusted if I talk a little bit about poop, but my career is surrounded with the intestine. So uh, it's just to show like how my science thing started there. So was one of the essays that I had to do in the parasitology was kind of gross. I'm not gonna get in details here, but then I went to the books and I was like, no, should be. I'm sure there is another way to do it that is gonna be less gross. So I went to the books, I found a protocol, I tested it on the side, and then I went to the lab owners. I was like, okay, can we switch for this protocol? Here's all the evidence that it works even better. It's much better. And then they end up accepting my suggestion and transfer and change the protocol for the protocol that I suggested. So they did all the rest of the validations and controls, and it's like, okay, yeah, we are gonna switch.
That's really
And
cool.
then Moji didn't have much of yeah, and Moji didn't have much of basic science research. So what I did, I decided to TA at night. I loved genetic, so was still like aficionated by genetic. And then I start TAing for my genetic professor for the next 2 years. So, and then every year I had to write kind of a thesis about something that I have learned and I want to explore more. And one of the things was that one year I wrote about like how you could go and collect a liquid amniotic from pregnant woman, and then in the future maybe you could have some therapy that you could modify the disease and then have a healthy baby. No one knew about CRISPR back in the day
Wow.
or the other therapies, so that was like that's super cool. uh, and then I decided that I want to do internship, so I changed my school hours for nighttime, and then I would take the bus in Mogi at 5 a.m., go all the way to USP. I went there, I knock on the
Wow.
professor's doors. I was like, can you give me a position here? And then I found a professor there, Rita, and then she's like, I don't have any openings, but I know that my husband, that is also a professor here in the microbiology department at work with bacterial genetics, is looking for an intern. So then I scheduled an interview with him, and then I went there, had the interview. He's like, okay, you still need to get a better on English, because my English back in the day was like not so good. And just a note for the audience, all the literature for science, most of it is in English. So it's a very important skill to have. So then I was like, okay, I can study English, just give me the position. So for 1 year, I was going at 5 a.m., getting to the bus, going to Sao Paulo, and the traffic is like horrible.
Yeah.
So it was like almost 2 hours and a half. So that is what my next set of sleep. Stay there in the lab, super like thrilled that I was having that opportunity, and then go to school, to college until like 11 p.m.
Oh my God.
and then back home. And that was like my routine. But I was so happy that I was like finally having my dream coming true. and doing like real science and work with like amazing scientists. And my PI there, Professor Luis Carlos Ferreira, was just like perfect mentor. He would uh, have meetings with me and like teach things from the basics. And I had also a co-mentor, Betis Brojo, that was like also like she was the lab mom and teaching me everything. So, and then I asked him like, I want to keep going, and was finishing college. And he's like, okay, we can get you in the master's program. And then I prepared all the documents for the master's. And then that was a time, I think it was 2002, that was no fellowships at all. And I needed a fellowship because then I needed to move to São Paulo. I couldn't stay at my parents' house anymore and keep doing this crazy
Yeah.
trip every day. And then he's like, and then one day he comes back from FAPESP, that is the government agency from São Paulo that gives fellowship, and say like they are really encouraging people to do direct PhD. That was not a thing back in Brazil in 2002. People would do the masters, finish the masters, and then start a PhD. And he's like, I think with this 1 year that you have been here in the lab doing this project, I think you can do it. So we changed everything, and then I started my PhD. That was like super, super cool.
I absolutely love your journey. I absolutely love it,
yeah.
Lily. And you have such a grip, right? And you always knew what you wanted, and you fought for it. And it seems to me that you had a lot of good family influence as well, and the support you needed, and your will for sure to endure all those travels and to study and to work on the same time. So I absolutely love it. It's an amazing example to have. And when we were talking about your work back in the days, and you mentioned genes, you mentioned poop. It just reminded me that I have to introduce you to one of our future hackers, Dr. Cliff Hahn. He used to work many decades ago in the Human Genome Project. And he recently found out a cure for allergy. He created those lollipops and toothpaste. And the way he discovered, he started his research by examining his own poop as well. So, and I was like, okay, those guys have a lot to talk about,
Mm-hmm.
Anyway, so then you got your PhD. Go ahead.
No. I finished my PhD, and during my PhD, I also wanted to go abroad and see how science was made outside of Brazil. So I wasn't like my professor's office all the time, like, can you send me? And then he ended up like finding a part of my project that I could do abroad. So I went to University of Oklahoma. I stayed 4 months there, working, doing a lot of bacterial mutagenesis. So because my PhD project was on vaccines, Salmonella vaccine for GI disease. So then I went there and I did mutagenesis. That is like you change some parts of the bacteria, so then you can now make a bacteria that the body can recognize it for 2 different diseases because you inserted a piece of the other bacteria. So then I went there to learn the technique and make my constructs. And then I finished my PhD. And then I was looking for other possibilities. And then I tried to come here to the US back there, but didn't happen. It was just like things. I say that things are meant to be the time that they are meant to be. So then I got a postdoc. I moved to Ribeirão Preto. Got all my stuff the day after my thesis defense and moved to Ribeirão Preto to start a postdoc there.
Wow.
And and there I got a 1-year fellowship in one lab, and then I ended up meeting another professor, Dario Zamboni, that was working with something super different. and super cool. He was hired. He did his postdoc at Yale, and then he comes to he was a new professor at the University of São Paulo in Ribeirão Preto campus. And then he's like, okay, yeah, you want to work with me? You have like this expertise that would be good to my lab. And I was like, yeah. And then I can learn more about innate immunity. That is something that is super new, because new, I mean like 20 years, that people start to see that our body, like we know about immune responses that are built over time. We know that if you get infection for something, then your body is going to get a memory, and this memory is going to fight the pathogen the next time. And then immune response was kind of known as a thing that was kind of unspecific. Something that will, just like you see, your body sees a bacteria, a virus, then it's going to mount this immune response just because it's something that is not self. And then, and keep in mind this word, not self, because we're going to talk more about it. But then they discovered that no, like our cells evolutionarily developed receptors that recognize little parts of the bacteria and the virus and start this whole cascade of immune activation. And then that was then my project back there, and I was working with lung. And then we had to do new constructs, cell engineer. And then he made this contact with Dr. John Kagan at Harvard University, and he asked if I could go and spend some time in his lab learning how to do this genetic manipulation on eukaryotic cells, in the case macrophages, that are one of our innate immune cells. So then I was exposed to like Harvard.
That's amazing.
Nobel Prizes people giving seminars. It's just
how
like,
did it go? And how was like Brazilian
realized,
women in science having this amazing experience in Harvard school, medical school? How was it?
was just like boom. Like my mind was just like, oh, there is so much. There is so much around, so many people, so many interesting people to collaborate, to talk, to learn, and so many cool things happening everywhere. But it was no one thing that I realized, that because we Brazilians are so creative, we can adapt to anywhere, and we have a lot of smart Brazilian people, like lots and lots of really good scientists, and people like they would fight to have a Brazilian in their lab.
Oh,
because we are hardworking and creative people. Because we don't have all the tools.
That's the thing, and that's a shame, right? Because we have brilliant minds here, but it lacks resources and it lacks opportunities. It lacks, government investing on that, and then people like you end up just going abroad for better opportunities, right?
Yeah, that's exactly what happened. At some point, I was in a lack of fellowship, was no fellowship available, and then I had to ask for family support. And you're 30 years old, you don't want to ask for family support. You don't want to not have a salary, not have savings. And this is another thing. In Brazil, the scientist position, a postdoc, is considered just a training and not considered a job. And here, a postdoc is a job. You are a junior scientist, getting independent, and you have all the benefits that as any other work. You're not studying anymore. That is, people normally confuse this postdoc, and they're like, "Oh, you have so many postdocs." That's no. My highest title is a PhD. Postdocs are experienced. So you are a trainee in labs. But then you are more independent, you're running your projects, and that from that project might even come up the project that if you're gonna go become a professor in a university, that project might be your research line. So your PI or supervisor is going to give you a project, you can come up with ideas and then you can start your own lab out of that idea. So I think that is like something that in Brazil, I'm advocate to change the law because the way that it is, it's too hard.
Yeah.
Like you were like 30, 35, it's kind of, you never had a job. And people say like, how long more are you going to study? I was like, no, I'm not studying. I work more than anyone else. I study for my job is about study. I have to read all the time. I have to be on top of everything.
Yeah.
But no, I'm working really hard.
And then from Stanford, you went from Harvard, you went to Stanford, right?
No, I was in Brazil for a while, and then I saw that it was not a lot of professors opportunity, and I was I was like, I don't want to be on fellowships anymore. I want to have like a job.
Yeah.
I tried to get a position in University of Rio de Janeiro, but then I would start seeing that people that was here for they did like a full postdoc outside, they were getting better chances than me. So then I went to a conference, Immunology conference in Brazil, that I saw that a lot of people from other countries were going to be there, professors that I knew and people that I didn't know, but back in the day. But then on that conference, I told my friends from the lab, I was like, I see you guys when we are back. I'm gonna do network here. So that is how I ended up in Stanford. One of the talks was a postdoc from this lab from Stanford, and I really loved her talk. And I knew about her supervisor, and that she was a great woman, like great on the field of salmonella. And then I talked to her after the conference. I was like, oh yeah, I see that you work in Denise's Monarch lab, and how is it? She's like, oh, Denise is just amazing. It's like, oh yeah, I'm thinking of applying, and if I applied for her lab, would you mind advocate for me that you know me? And she's like, yeah, definitely. I will for sure tell her that I met you and you are amazing scientist and very curious and hardworking. So then I sent an email to her and I told her like, I want to work with you. And then she's like, okay, let's get on a phone call. I was like, oh my God,
Yes.
this is becoming real. And then we talked over on a phone call and she's like, yeah, when can you come?
Wow.
And I was like, okay, I can go for an interview. And then I went for an interview. Fun fact, their family help again
Of
because
course.
my fellowship was so low that I didn't have the money to go. And I asked her if she would sponsor my trip. She's like, oh, I can sponsor half of your trip. But the other half, either you go interview to another person and ask them to pay the other half, or you find a way. I was like, okay, I will find a way. No worries. So then I call my brother. Hey, can you help me? And he's like, yeah, of course I can help you. So I came here to the US to the interview, like with barely no money.
Wow.
But I made it. And then, and after the interview, she was like, okay, let's start to work on your visa.
Oh, that's amazing.
I was
That's
like,
amazing.
yeah. And no, I need you like before the end of the year. This was August. October 21st, I was here.
Wow.
I was arriving and starting. It was kind of like 2 months. Let's wrap up the paper that I had to publish in Brazil and get things done and do the visa stuff and everything. And because here some universities have a rule that if you have more than 6 years of a postdoc, you cannot be a postdoc anymore, to force also the professors to get their students to move on, like to not keep them in the same position. So then they have to pay them higher salary and everything. So then she opened a staff position for me as a research scientist. I was like, oh, even better.
Of course.
So yeah, so that's how I end up getting at Stanford and working with these amazing scientists, and that was just like, oh my god, I can't believe the imposter syndrome wouldn't even let me tell people that I got a position at Stanford.
It's so amazing. How was this experience in Stanford, and how it compared to Harvard? And then I know that you actually moved from the academia life to the industry. So I also want to know everything about it, which is what you're doing right now, right?
Yeah. So Stanford and Harvard is like both amazing institutions. That's why like they're the best
Yeah.
of the world. You see like lot of smart people, but also like I feel because not everything is flowers. There is a lot of pressure too. People feel a lot of pressure for being there, and I had this thing on my back too. I was like, no, I'm at Stanford. I need to be the best. Like I had a friend that would tell me like, stop working, no, stop. Like you need to have a life. And I was like, no. I didn't move all the way to Brazil to Stanford to be having weekends. No, I need to work on the weekends too. And he was like, no, stop it. And then also like my mentor, she was super nice, and if I would have like a long day experience, it's like, oh, just go home, relax, and don't come. I don't want to see you here tomorrow. So I see that there is a lot of people are more worried about work-life balance.
Yes, and
here
mental health,
nowadays.
right? Yeah.
Yeah. So yeah, so then I was here, first country to, okay, I'm gonna get my paper, and then I'm gonna get my full experience, and then I will go back to Brazil, and then I start seeing. First, the situation in Brazil was not good for science. Was not a lot of money. All like people there was kind of, I want to get out of here. There is no more money. I'm closing my lab. I saw some people like trying to get money online or fellowships and stuff like that for their students because was chaotic. And then I started looking what was here, and then I was like, which pathway do I want to go? And I always had this feeling of doing something that I could give back to the society. And by being the Silicon Valley, you are surrounded for so many biotechs. And you hear all the time, like people leaving Stanford to go to a biotech or to start a new biotech. So then I started like, okay, I'm going to open my LinkedIn. I'm going to start making that work. And then I will see what happened. And then the first barrier that I found was the visa. I got some people just like try interview, and they say like, oh, if you don't have a green card, I cannot get it. I cannot hire you because I can't sponsor. So then I went to the process of getting a green card because as a scientist, we can get a national interest waiver. So that was a fun fact. When I got that letter from the American government saying that how much they appreciate that I want to stay in their country, it was kind of like, was a bittersweet feeling.
Yes.
Because it's like another country is giving me the permission to stay here because they
value.
They can see my value.
They value exactly. Something to think about.
Yeah,
that's for sure.
Then I started like So then I started like I was doing my job at Stanford and working with the green card, and then came the pandemic. Just right before the pandemic, I got my green card, and then with the pandemic, everything changed.
Yeah.
So then after I finished my research at Stanford, I was ready to submit the paper, and then Denise again. She's like, it's time for you to move. I would love to have you for the rest of my life.
Oh my God.
But I'm thinking about you.
Yeah.
And that's what you need to do. If industry is what you need to do, I'm gonna help you. If you want connections, and was super cute, because then I got this position at the company that I worked, that all the job description was matching my expertise.
Yeah.
And just some side notes for people that are listening and looking for positions. They were looking for junior scientists, and I had already 14 years of experience, and I tried to apply anyway. I was like, let's see if the people will look
Yes,
at
yes.
my CV.
Let them get to know me, right?
'Cause
Let them get to know me so they can create a position
yeah,
that is just made for you, right?
yeah. So then I got there. So I was interviewed, and then my manager asked for references, and then my Stanford manager, she interviewed him too, to make sure that I was going to a good place. and
Oh, that's nice.
And then I got this job to work with autoimmune disease and with gut again. At Stanford, I was working with gut, and there is a interesting story behind it. Stanford has a big history on studying Salmonella disease, and there is a story, like the real story about how Stanford was built. I don't know if you're familiar with it.
No.
So the Stanford family was a very rich family that had this farm in the Bay Area called Stanford. So Stanford is a city. And then they had a son, Stanford Leland Jr., and their son died at age 14, 15 with typhoid fever that is caused by Salmonella infection. So then when he died, the parents was their only son. So they went to Harvard and asked Harvard, can we give money and you build a building and put our son's name on it? And they kind of like were not interested in that offer by the time. I don't know exactly the details of this part of the story, but then what happened is the Stanford parents, they decide to construct their own university to put the name of the son as an honor to him. Yeah.
Wow.
And now it's
And that's how it began. Yeah.
like, because there is this
I
like
had no idea.
little competition between Stanford and Harvard. Everyone likes to say, you see, Harvard didn't want a building with a Stanford name, so now
You see what
they have
happens.
another university that is equal better.
That's really cool.
Yeah, so is a fun fact. Yeah, and the lab that I was working is a Salmonella lab, so I was studying the gut, and I was studying something very fun there that was the typhoid fever. Do you know that typhoid fever, there are people that get very sick and die? And there are people that are walking around here that they carry their bags of Salmonella and they don't know about it.
Yeah, so I remember you told me about the Typhoid Mary story. Let's go into that because I don't know how popular it is.
Yeah, so that is the whole thing. Typhoid Mary, she was an Irish woman that moved to the U.S. At a young age, and then she started working as cooking for rich families. And then she would cook for them, and then go get another job, and she was completely healthy. She had no disease at all. And then at some point, they started to see that some families were all getting a salmonella infection. This was early 19s. And then an investigator decided to go and track what all these families had in common, that some people were even dying from salmonella infection. And then they got to Mary, Maryland. That was then became the famous Typhoid Mary. She didn't have good habits, and the transmission of salmonella is oral fecal transmission. So I don't need to say much here. And then she was spreading salmonella to all the houses that she was working. So then they took her to the hospital, but she refused treatment because she was not feeling anything. And then she changed her name and went back to work for other families. And then again, they found. So then they ended up like locking her in a hospice because she would refuse treatment because she had no symptom. So in the lab that I worked at Stanford, we used a model that are little mice that they can be like Typhoid Marys. So to try to understand, because this is a very interesting thing. What's the factor that makes some people so sick and die?
Do we have this answer already or not?
Some people just... But really, there is multifactorial. One of the things is the microbiota. So the bacteria in our gut can produce some metabolites, and these metabolites can feed salmonella and can also feed the immune system. And so just out of curiosity, we have more bacteria in our body than human cells. So, but they are good bacteria. Yeah. They're there to protect us, and we coexist with them. So there is a multifactorial thing. There is also like some cells in our body. So people that have this asymptomatic, the mice that had the asymptomatic, they have an increase in a cell type that is called T regulatory cells. So these T regulatory cells were kind of controlling the immune response. Because sometimes we die not out of infection, but the way that our body reacts to that infection.
Yeah.
So I did an experiment where I removed these cells from the mice, like genetic engineering model, and then they all get very sick. And then because one of the immune cells were then proliferating too much, so then if I went ahead and then dumped that other type of cells, then these mice would get back better and living longer. And so, it's the immune system is like, there is so much that we still have to learn.
Yeah. And so from your very beginning of your career, even before that, when you were studying and then with all your international experience, and now moving to the industry, the private world, right? You faced so much technological advancements, right? And I'd like to cover that a little. So actually, I'd like to cover two things. One is the radical change that it should be, that I think that you face moving from academia to the private sector, right? It's one. And how your work changed, and also how technology has been helping. What I've been talking to, we've interviewed a couple of scientists, and one of them, someone that for sure you have to meet, which is Cesar de la Fuente. He's the director of the machine biology at the UPenn University. Amazing conversation. And we already covered how technology has been helping evolve the findings, right? And the studies, and how we can deal with volumes and different variables, and how we can work with transversal areas of knowledge plus technology to get into those answers. So let's cover that.
Yeah, so when I started my career in Brazil, and also the technology that was back in the day, one experiment would last like 3-4 days. And now with things going further, like all the evolution thing, the same experiment that would take me 3 days to do, now I can do in half day. Just the way that the technology and these things are also now Brazilian people can have access to it, but it's more expensive. So some labs will not have the money to have these technologies, but big institutions, they have it very comparable. And then from academia to industry. So in academia, you are there doing most of the time more basic science, your end product is a publication. That is the way that you're gonna give to the world what you did. So you're gonna publish it in a manuscript form where you put all your results there. And on industry, it's different because at least where the field that I'm doing, because we get this basic science that is produced, and then we try to make it to become a medication for people. But we need to understand how things work. Without understanding how things work, we cannot develop assays to test if the drugs are gonna work. And one thing that is also different in the industry is the throughput of things. You're doing a research, the number of things that you're doing is you will repeat this 3 times to make sure that that's okay. But then in industry, because then you're gonna be delivering medication that can save lives or can kill lives. So your responsibility is like making sure that you're doing the second one, you're saving lives. So that was the first thing that I, at my interview, I was like, how do you know when a drug is ready to go to it? And then the answer that I got first is like, you first need to make sure that it's not gonna make more harm than good.
Yeah.
So, so then we have like a lot of machines. We have a robot in the lab that will do the experiments in a way that they are more reproducible. So these technologies are now much more available. So we were even discussing it at dinner yesterday, if AI is gonna do our job. Because if we get robots to do the experiments in the lab, and if we teach them how to do it,
I think, you know what? I think what we've been discussing here is that for sure it will take the jobs of people that don't know how to use it as a tool, right? And we just need to make sure that we are making the best use of AI and the technologies, of course, in a safe way, in an ethical way. We have to be using it right, imputing the right set of data and everything, but understanding how to use that. So for people that understand how to use it and use it as a tool, you are many steps ahead. For people that know, I don't know that, then I don't know how long it's going to be relevant to the market, right?
Yeah. No, and for sure, like I can see here in the conference how bioinformatics are now a need, because we have tools now to produce so much data. As I told you before, it would take 3 days to do an experiment that would be a lot more simple. Now in half a day you can get some done, and then gets to how we are going to analyze that much of data. So then comes the bioinformatics that people are programming and doing machine learning to get this data analyzed in the right way to give us the right response. Because I cannot go anymore and look one by one data by eye and see, oh, this group is better than this other one.
Yeah.
This is more promising or not, because there is so many variables that it's impossible to analyze. So we need
so and tell me, so you are in this conference right now, right? You just got into a separate room to talk to us. Is there anything like hot new that is out there that maybe you haven't heard before, or it's new for people out there you knew, but it's not so spread up, that you could share with us?
There's a lot of like really, really interesting thing, but one that I really found amazing, one presentation that I saw here, that they were showing that kids that were exposed to RSV, respiratory syncytial virus, they are more prone to have asthma in the future, because the way that the virus changes the genetics of the cells, in the future these people are more prone of having autoimmune disease. So, like what you got
Oh,
exposed as a baby might affect your whole life.
wow. And instead of the opposite, right? Because sometimes, general people think that if you're exposed to some sort of disease when you're young, you're actually going to get stronger when you get it again. And it's quite the opposite, right? If you get it when you're a kid, you may suffer even more when you grow older.
Yeah, so that is the intriguing, and because also, yeah, we need to be exposed because
Yes.
our immune system, when it's developing, is going to create all kinds of cells. So that's the other side of it. And then if
Yeah.
you're not exposed to microbiota, but not to disease, that is the thing. Like if someone is cold, they should have a cold, should not go and visit a newborn baby. This is not going to make them stronger because their immune system is still developing. But the contact
Yeah.
with the mother and that is uh, make it that the microbiota is going to start building, and then the cells are going to start like some cells will be killed by then. They are not going to proliferate. So because it kind of experienced some antigens and now they become memory cells. But if you have too many cells there that are laying around and they are not seeing any antigen, remember that I told you, keep the word no self and no self. So self is everything that is from our body. And then if you are not exposed enough to external, if you put your kid in a bubble and not let them face the words, then you are going to start having that cells that they have nothing to do. So then they can start to be autoreactive. So they can start to recognize proteins from the body and attack the body. And this is what is autoimmune disease is.
Yeah.
So you have a bunch of examples like
Yeah.
psoriasis, IBD, that is what I work, that is the inflammatory bowel disease. So your immune system is reacting too much, then now is destroying your intestinal wall. But then is one disease that is multifactorial. Yeah, allergies are being very related to autoimmune things that like a kid, because then your body, when it sees that thing for the first time, it overreacts.
Yes. So you've mentioned a lot during our interview how many things are multifactorial, right? And so I have a question for you, because on the same time we are seeing this trend, this move of personalized medicine, right? Being more customized to people own body, leveraging personal data, using wearables, using many other technologies that are around, tailored treatments to individual needs. But on the same time, those triggers in autoimmune and chronic diseases, they're so unique, they're so individuals. That do you actually foresee this is something viable for the future, to have those more very focused and personalized medicine through technology, or do you think that is more, this is sci-fi?
No, it's real and it's happening. There is something called biomarkers. And now when we are discovering drugs, there is on clinical trials, they are seeing that if they find the biomarker for that target that they decide to do for that disease, so people that are biomarker positive, they are most likely to be in remission and be cured of the disease, while the biomarker negative people are less likely. So this is something that, at least on the field of IBD, because it's such a multifactorial disease, they are looking for multiple biomarkers. Some of them is the microbiota. So which bacteria you have in your gut. If you have certain populations, you are more prone to that treatment to work than others. Or if you have some genetic mutation for that target, so you're going to have an overexpression of some protein that is then in the immune system. So if you know that person case is because of what is causing IBDs, that protein, then you know that that drug is going to work better. So this is something that is going to happen in a near future. The screening before.
That's really
They're
cool, and
also
I
like
hope
at
it's
the
actually accessible, right, to general public.
yeah, yeah, to be, because if they find one thing that is, then you can just test for that one thing, and yeah, okay, these patients should have this treatment or the other one because they are positive or not for these biomarkers.
Yeah, yeah, that's really great. Listen, Liliana, we are getting out of time, unfortunately, and I have a last question for you. So, having had this amazing journey of yours, for sure, a lot of self motivation there, inner strength, right? And really grip. I want to know if you have any advice for our listeners that are venturing into the science world. You are also a big advocate, as I said when I was introducing you, for women. You mentor women in the business world. You help them negotiate as well, right? Uh, so, if you have any advice to whoever is listening to you right now that could use a source of inspiration and strength not to give up in the science world.
Hey, so yeah, what I would recommend first is networking. Don't be shy. Go talk to people, email people. You're gonna hear a bunch of no's, but you're gonna hear a yes too. So go and look for it. And for young women in business career, um, negotiate your salary. Make sure that of your value. Do a research of the salary competition. Ask friends how much they're making. I know that can sound a little bit rude, but you can ask a friend. You can go on Glassdoor and see how much people are making on that position. Because even HR people say that women tend to accept lower offers than men. So they will offer the same salary for men and for women, but we accept less. Why they're gonna give us more? So it's part of the society still to get things more equivalent, but it's also part of us to empower ourselves and make sure that we are getting equivalent salaries. So I've been talking to a bunch of new people.
And yes, and yeah, I do like what you say, especially when it comes to women. I don't know if you feel the same, but we don't do that enough for some reason. Like, if you have a group of women friends, or even the mothers at your school, your daughter's school, or something like that, like, we just don't talk about work as we should. Like, when we are networking, is usually the topics about life, about health, about which are amazing, but we need to talk also about the professional life and exchange more and help each
Yeah.
other more, right? Because we don't do that naturally. It's something that it's even weird if you go to the school and say, listen, but what do you do professionally? Like, people, we're just not talking about that enough, right? And this is a way that men just do that naturally, and maybe we have to just learn how to do it more frequently. Maybe it's just
Yeah,
cultural. I don't know.
And the work is everything is a work. Like maybe a volunteer work that you do on the side, like, or being a full-time mom. It's kind of so much that you're learning there, how to take care of your baby and everything. That is because this is something also that is different for women than men. This kind of becomes more the responsibility of the woman to take care. Most of the cases, I'm not going to generalize, because I know that some dads that stay at home to take care while the woman goes back to work. So, but in general, what we still see is the responsibility falls more towards to us. And but yeah, we need to network more and know what each other are doing, and make collaborations. That is how I got to know you through network.
Exactly. Let's get networking, people. Let's get it going. Lilian, it was really great talking to you, and talking about that. Welcome to Hacker Network as well. And I'm sure you're going to meet pretty amazing people that we've talked to in the past, and they're very interesting to your field as well. So let's get this going. Thanks everybody for listening, and I do hope you can use Liliana's stories as inspiration for your life as well. Thanks
Thank you so
everybody.
much.
Future Hacker. Life. Path. Future.